Welcome back. Today we're doing Chapter 1, Lesson 9. This is 7th grade math, and today we're going to talk about direct variation. So direct variation is a relationship in which two quantities have a constant ratio. Constant of proportionality is the constant ratio in a direct variation. So what does that mean? So let's go through. The distance y a car travels after x hours can be represented by y equals 65 times x. The table and the graph also represent the situation. So in this case, y would equal the amount of miles traveled. 65 represents the speed, so they're going 65 miles an hour. X represents the number of hours. So we would plug these things in. Y equals 65x. Again, 65 represents the speed, so this is miles per hour. X will represent hours. How many hours are we traveling? Y will then represent how many miles traveled. All right, picking up where we left off. So again, y is how much is traveled, and that y is going to be the dependent variable. It is dependent on x. X will be the independent variable, which means whatever x equals will change y. So if we travel, for instance, for 1 hour, x will equal 1. 1 times 65, y will then equal 65. Y means we only traveled 65 miles. If x equals 2, then it'll be 65 times 2. 2 times 5 is 10, carry the 1. 2 times 6 is 12, with plus 1. So then we would have traveled 130 miles, which was what y would equal. Y would equal 130 miles. So y is dependent on what x equals. And x will equal whatever it is depending on what we've done. In this case, x will determine how many hours we have driven. And then 65 would be the constant rate of speed that we're traveling. So in this example, we are graphing how much we have traveled. So over time, and it kicked me back up. So over time, in 1 hour, no draw, draw. In 1 hour, we would have traveled right there, and this would be representative of 65 miles. Remember, this is going up by 50 each time. 2 hours was 130, 3 hours was 195, 4 hours was 260. Fill in the blanks to find the constant ratio. So 195 was 3 hours. So I'd fill this up with 3. In 4 hours, we went 260 miles, according to our chart here. The constant ratio is blank miles per hour. It's 65. Each one goes up 65. 130 plus 65 should equal 195. And it does, 195. So the constant ratio is 65 miles per hour. We are going 65 miles each hour. Let me erase all of this and keep going. The constant rate of change, or slope of the line, is change in miles, change in time, which equals to 195 minus 130. So again, we're taking 1 point. We're taking 0.3 and 0.2 in this case. 195 minus 130, which would equal 65. 3 minus 2, which would equal 1. So they're saying that my slope is 65 over 1. And again, this is just 65, so my slope is 65. Write a sentence that compares the constant rate of change and the constant ratio. We would say that they are the same because the car is traveling at a constant speed of 65 miles per hour. So every hour, the car would have traveled 65 miles. So that would be something comparing the constant rate of change and the constant ratio. They would be the same, and the car is traveling 65 miles per hour. Every hour we drive, we are getting 65 more miles of travel in. Direct variation. Now I know some of this seems kind of common sense, but there are names for this. So direct variation is a linear relationship which direct variation and the ratio of y to x is a constant. So again, like we did here, it was 65 miles per hour. This would constitute direct variation. We say y varies directly within x. So again, y depends on x. Y is the dependent variable. Whatever y is will depend on what x becomes. So for example, let's say somebody makes $5 per hour. X would represent how many hours they work, and y would represent how much they get paid. So if they only work 1 hour, y is going to be $5, how much they get paid. If x is 3 hours, they work 3 hours, 3 times 5 would be $15, so y would equal $15, how much they would get paid. So x is the independent variable, and y is the dependent variable. X is going to be whatever we choose it to be, or however much we travel or work, or whatever x is measured in. Y will be dependent on x. So our example here is y equals 2 times x. So let's go ahead and say, let's make this a little bit more relevant. Y will equal the amount of videos I can record, and x will represent 1 hour. So for every hour, I can record 2 videos. So I would make a table like this, x and y. So in 1 hour, I could record 2 videos. In 2 hours, x would be 2. Plug in here, 2 times 2 would be 4. I could record 4 videos. In 3 hours, I could record 6 videos. In 4 hours, I could record 8 videos. In 5 hours, I could record 10 videos, and so on. The constant rate of change here. So again, we're going to take one point and the second point. And remember, it's y2 minus y1 over x2 minus x1. So this would be 4 minus 2 over 2 minus 1, which would give me 2 over 1. My rate here is 2. It's basically saying I can make 2 videos in 1 hour. So it's not going to change. So that is my constant rate, is 2. So in this example that we have here, y equals 2 times x. And then we'd have numbers lined up here, numbers lined up here. That'd be 1, 2, 3 for hours. Up here we'd have maybe 2, 4, 6, 8 for the amount of videos, and it would just go up at a constant rate. The example y equals 3x is a different example, and it would be, say, same thing. Let's erase just what we have. Let's say, oh, I don't know why I erased the x's. The x's could have stayed the same. If y equals 3x, so now suddenly I can record 3 videos in 1 hour. I would record 3 in 1 hour, 6 in 2 hours, 9 in 3 hours, 12 in 4 hours, 15 in 5 hours, and notice that each one is going up by 3. My constant rate of change here would be 3. Each one is going up by 3 when it goes up. And then again, I could take y2, so we'll start with this one. We'll say 9 minus 6, y2, y1, and then x2, which would be 3, minus x1 would be 2. This would be 3 over 1. My constant rate of change is still 3 over 1. When two variable quantities have a constant ratio, the relationship is called a direct variation. So again, when there's a constant, when each y is going up by the same number, each x is going up by the same number, it is called a constant of variation. The constant of variation is also known as the constant of proportionality. So same thing. In a direct variation equation, the constant rate of change or slope is assigned a special variable, or k. So again, up here, y over x equals k, or y equals k times x. All right, continuing on. When two variable quantities have a constant ratio, we went over this. Okay, so an example here would be the height of water as a pool is being filled is shown in the graph. Determine the rate in inches per minute. So here's time, and here's 1. Can't really tell, but we can use 5 and 10 to solve this. So we're going to use 0.52 and 0.104 to solve what our slope is. So again, it is y2 over, sorry, y2 minus y1 over x2 minus x1. So we have, let's go ahead and get a new whiteboard. So our points again are 10, 4. So this is the 2. This is x and y 2. So I'll say 1 and 2. Oh, sorry. Both of these are 2. Because remember, 2 is going to be the bigger of the 2 points. And then the other one would have been 5 and 2. And this will be x1, x2. Or sorry, y2. So again, we have our equation is y2 minus y1 over x2 minus x1. y2 is 4 minus y1, which would be, this is not y2, this is y1, which would be 2. And then x2 would be 10 minus x1, which is 5. When we do this, 4 minus 2 is 2. 10 minus 5 is 5. So we still ended up with our first one. I can't really, well, I can if I divide them both. Okay, let's pause there. Since the graph of the data forms a little line constant, the rate of change is constant. Use a graph in order to find the constant of proportionality. So yeah, if I were to divide both of these by 5, calculator, 2 divided by 5 equals 4. Remember, we want the bottom number to be 1, so hence why I'm dividing by 5. This would be 0.4 to 1. And this means that it's filling up 0.4 inches per second. And then all of these, as you can tell, would all match up if I were to divide all of them by their denominator. So if I were to divide 4 by 10, 4 divided by 10, it would be 0.4. 6 divided by 15, 0.4. 8 divided by 20, 0.4. Therefore, our constant rate of change is there. The pool fills at a rate of 0.4 inches every minute. Let's go to determine. We'll do this one. Determine direct variation. Not all situations with a constant rate of change are proportional relationships. Likewise, not all linear functions are direct variations. So you're going to end up with these kind of like extra charges. So for example, pizza costs $8 plus a $3 delivery charge. It doesn't matter how many pizzas you order, you have to pay $3 for delivery. So it doesn't matter if you buy 2 pizzas, 3 pizzas. It's not $8 plus a $3 delivery charge per pizza. It's a $3 delivery charge. So show the cost of 1, 2, 3, and 4 pizzas. Is there direct variation? So we do 8 plus 3 for 1 pizza, which is 11. 2 pizzas would cost me $16, but with a $3 delivery fee, it's $19. 3 pizzas at $8 would be $24, plus the $3 makes it $27. And 4 pizzas, 8 times 4, would be $32, plus the $3 delivery charge makes it $35. So each one does not go up by the same amount. Cost of pizza, 11 to 1. So if I buy 1 pizza, it's $9.50. Wait, what? Okay, let's pause this. 11 over 1 would be 11. Oh, they're going for each one. So 11 over 1, it costs $11 to buy 1 pizza. 2 over 19, or 19, $2, 2 pizzas are $19 makes 19 over 2, or $9.50 for each pizza. $27 for 3 pizzas makes 23 over 3, or $9 per pizza. And then 4 makes it 35 over 4, or $8.75 per pizza. So the more pizzas you buy, the quote-unquote cheaper it is because of the delivery fee only being there for one delivery, not per pizza. So these are not constant. There's not a constant rate of change here. Therefore, even though the line is straight and it doesn't go through the origin, that's going to be a big one. It does not go through the origin. There is no direct variation. So remember, we start at 0. They charge us a $3 fee, period. Doesn't matter how many pizzas we order, we get a $3 fee. So it's not going to go through 0. It's going to start at $3 and then the line will go up. Therefore, this is not an example of direct variation or constant. It was direct variation, or the other name for it was constant of variation, because there is no constant. 2 pounds of cheese costs $8.40. Show the cost of 1, 2, 3, and 4 pounds of cheese. Is there a direct variation? Explain. So I can tell you right off the bat that there is going to be a direct variation because there's no hidden charge. There's no fee, or how Ms. Steiner calls it in the notes. Let's go look at the notes really quick. Ms. Steiner likes to call it a rip-off fee. There's no rip-off fee. There's no extra charge. There's no delivery fee, nothing. So if a pound of cheese, going back to the question, if 2 pounds of cheese cost $8.40, show the cost of 1, 2, 3, and 4 pounds of cheese. Is there direct variation? So again, your ratio is this. So the cost is $8.40. That's for 2 pounds of cheese. We want that 2 to become 1 because we want to know how much 1 pound of cheese is. So we're going to divide both by 2. So half of 2 is 1, so we made it 1 like we wanted to. 840 will give me 420. So each pound of cheese costs $4.20. This is your rate of change. So if you wanted to find out how much 3 pounds cost, you just multiply both by 3. And that would give me 3 pounds of cheese for 60 cents. 4 times 3 is 12. So $12.60. 4 pounds of cheese, we multiply this by 4. That would give me $16.80 for 4 pounds of cheese. Because 4 times 4 is 16. 4 times 20 would be 80. And then 5 pounds of cheese would be 21, I believe. Let's see. 5 pounds of cheese. 5 times 20 would be $1, so I have $1. 5 times 4 would be 20, plus 20 plus the 1 would make it $21 for 5 pounds of cheese. So that is basically the lesson. So again, a constant rate of change, you're going to be able to tell if it's a constant rate of change or not based on the relationship between the two and the fact that there is no hidden fee. So again, this is an example of how much they would get paid. They are getting paid $12 an hour. 2 hours they get paid 24. 3 hours they get paid 36. 4 hours they get paid 48. Nowhere in the word problem does it say they get a bonus after a certain amount of time, or nowhere does it say they get paid, a flat fee, like say they get paid $12 an hour plus $50, like a signing bonus for being there. If there's any plus this or plus a fee or they get a signing bonus kind of thing, then there will be no direct variation because that extra money or extra charge throws things off. So again, direct variation will be there if it is constant. So again, the wages, the amount of miles driven per hour, how many things you can get done in a certain amount of time, as long as it's constant, as long as the rate is constant, the direct variation will be there. If there's a hidden fee, if there's a bonus, it completely throws everything off. So this is Mr. P. This has been a long, arduous chapter. Again, please make sure you guys are paying attention closely in class. If you guys have any questions or concerns, you guys know where to reach me. I'll see you guys on the next one.